Hey, so now we're going to do testing for equality of population proportions for 3 or more populations. And again, we're going to have an example, and the example is located, just one second, let me find it. Okie dokie. Here's the example. Customer loyalty for automobiles. Suppose in a particular study, we want to compare the customer loyalty for 3 automobiles, Chevy Impala, Ford Fusion, and Honda Accord. And these are the population proportions. So P1 is the proportion likely to repurchase for the population of Impala, P2 Fusion, P3 Accord. And the question is we begin by taking a sample of owners from each of the 3 populations. Each sample contains categorical data, category, indicating whether the respondents are likely or not likely to repurchase the automobile. So category, would you repurchase? Would you not repurchase? Which category do you go in? And for me, I kind of like this when it's all on one page. And again, this is just for me, like synthesizing information. Like it's easier for me if I could see stuff all together at once as opposed to flipping between slides. So I'm just going to bring this down here, and then I have to bring this down and then bring it back up. I'm going to pause the video while I do this. Hold on. All right, that makes more sense for me right there. So that's the goal. This example really kind of gives us a sense of we're just seeing, customer loyalty for 3 automobiles, and we want to see, population proportions for 3 or more populations if they're equal. And so let's take a look just at the beginning, the notes here. And so using the notation, population 1, population 2, population K, so that would be like 1, 2, 3, 4, 5, 6, whatever, all the way up to K total. So this is 3 or more populations. So the hypotheses for the quality of population proportions for having 3 or more populations are as follows. The null hypothesis is going to be equality, and the alternative hypothesis is not all population proportions are equal. And so it's just telling us if the population proportions are equal or if they're not equal. And again, I'm going to get our little rule of thumb, our little heuristic for creating our, hypotheses. And I'm going to paste that here, right? So when we create our hypotheses, equality goes in the null hypothesis. And so the null hypothesis, right, is the assumption that all and equality goes in the null. Also, that's a rule of thumb. That's a heuristic. A heuristic, that word that I'm using, is just the fancy way, and I'm using it because you will hear this in life. It's a fancy way to say rule of thumb. Enabling someone to discover or learn something for themselves, proceeding to a solution by trial and error, or by rules of thumb that are loosely defined. It's a heuristic.
Heuristic.
So that's our heuristic for creating hypotheses right there, and that's how we create the hypotheses for this. So if HO, the null hypothesis, cannot be rejected, we cannot detect a difference among the population proportions. If the null hypothesis can be rejected, we can conclude that not all K population proportions are equal. Further analysis can be done to conclude which population proportions are significantly different from others, right? So here is our example, and if we start to put this together, I'm just looking here to see, I guess we need this additional information before we jump into the example, and I might have reordered these slides, and now I'm thinking that maybe we need this one first. And so to determine the expected frequencies, so we begin by taking samples, and then we determine the expected frequencies under the assumption that the null hypothesis is correct. But also, right, we're also putting equality into the null. Expected frequencies under the assumption is row total, column total divided by sum of sample sizes. So that's pretty similar to what we've seen before in this chapter. And if a significant difference exists between the observed and expected frequencies, the null can be rejected. And so, and I'm just wondering if there's a test statistic, and there it is. And then we compute the value of the chi-square test statistic, which is this, where we have observed frequency and expected frequency. The test statistic has a chi-square distribution with k minus 1 degrees of freedom. So that's our degrees of freedom. That should get a little highlight around it. So I'm just going to grab this box and put that around that right there. And we'll get rid of the gray and make that transparent, and we'll make this yellow, and we'll just bump that up to 8. There we go. K minus 1 degrees of freedom. Go away, Mr. Mosquito. All right, so now we could do this computation here. And to do this, to get the expected frequencies, we use that formula there. And so here it'd be to get the expected frequency of Chevy Impala. I'm guessing it's 125 times 312 divided by 500. 125 times 312 divided by 500 gives us 78. So we get all the expected frequencies here, and there are the observed frequencies. And then we need to calculate our test statistic. And to calculate this, I'm just going to move this down here. And again, I really like to see things all in the same place. I'm going to make this smaller because we could still see that. And I'm just going to bring this down here, and I'm going to make that smaller. And we could bring that over there. And then I'm going to just bring this down to like 14 is good. And then bring this down. And that is good. And now, it needs to go up just a touch, just like that little amount right there. Maybe it's a little bit more, a little more. And now what I'd really like to see here would be these, so not that one, just like here to there. Well, I also want observed in that. And so what is this one? This one is huge. And that needs to be made smaller because it's overlapping. So I'll bring that up like that. And now I could grab those guys right there. And did I get this one? Oh, that one is in that one. So that's why that goes all the way down. So I guess I could just do this. Those two. Wait, I want the owners. That one and Control C, Command C, and then here. And then I think I could move all these over. And I'm not quite. Maybe if I make that one smaller, it'll all fit. And I also need to make this observed. So I need to make this one all smaller. So I think I might be able to grab the corner and just shrink all those. Just looking to see if I get the shrink. I got to do them independently. There we go. Make that one smaller. But that doesn't like that. So we're going to make this one smaller. So there we go. That one's smaller. That still works. And we'll bring this one over. And we'll bring this one down. All right. You're learning a little bit about creating presentations also. So bring this down just a touch. And we'll put this here. Oops, got to copy that one. And move it up. Observed frequencies. And get rid of that. And expected frequencies. There we go. So when we calculate them, ideally this would just all be over here because it's like you read left to right. So I'm going to put all that here and right click it and choose order and say send to back. And then I could capture this one and move all that over here. All right, so I did all of that so that we could see our observed frequencies. So here's 69 for Chevy Impala and 120 for Ford Fusion and 123. And likely to purchase, yes, yes, yes. No Impala, no Fusion, no Accord. So that would be 56, no Impala. No Impala is 56. And then the expected frequency, there are those values. And then the difference between them would be this one minus that one, which is going to be -9 for here. And then square that. And then take that and divide it by, and here we really want our test statistic formula, which is right here. So I'm going to copy that and bring it over. And so here we're going to, once we get this, we're going to divide it by this. And so when we take this value here and we divide it by the E, 78, we get that. And then we add all those up, we get this. So that's, let's bring this over a little bit more. That is like 7.89 is our test statistic. Well, when we look at the problem, we want to do this with some degree of level of significance, right? Some level of significance. And so I'm just looking here to see if there's a level of significance. I'm looking for that alpha of like 0.05. And we have K minus 1 degrees of freedom. And so our degrees of freedom will be, we have 3, so we have 3 things, 3 categories in Paula fusion accord. So 3 minus 1 is going to be 2 is our degrees of freedom, and I'm not really seeing the alpha where we reject HO, null hypothesis, and here we have alpha, where alpha is the significance level. So let me pause the video and see if I can find the alpha. Hold on. Okay, so the only alpha I found is like way down at the end of the solution of the problem, and so it's right here, and it's even incorrectly kind of set up, and it's like alpha minus 0.05 and 2 degrees of freedom. Well, if we look at our table, and it's alpha is equal to 0.05, and so that should be equal, not minus, because if you're going to talk about the significance level, the level of significance, right? Where's our diagram? And our diagram, this mosquito is just eating me alive. Ooh, I don't have a diagram for this yet. I'm going to have to draw a diagram. All right. But when we talk about that, right, that's going to be our tail. And so, yeah, hold on. I'll draw a diagram and I'll show it all to you. Wait 1 second. Oh, this mosquito. All right. Waking you up, right? If I clap every now and then. Oh, man, mosquitoes. You know, there's that saying that if you think that you're too small to make a difference, think of a mosquito. So here is here's the little diagram, and I put us in at a 0.05 level of significance because, and here you can see alpha 0.05 level of significance, and then we also have 2 degrees of freedom. So 3, you know, you take your k, you minus 1. And we saw that, right? To get your degrees of freedom, it's k minus 1 is somewhere up here in the slides. K minus 1, degrees of freedom, we highlighted it. Where is it? Degrees of freedom right here, k minus 1 degrees of freedom. And so we have 2 degrees of freedom. And at 2 degrees of freedom, and here's, you know, the thing, 2 degrees of freedom is right there. At 0.05 in the right tail, we have 5.991 as a critical value. So we have 0.05 here as our p-value. And 5.991 as our chi-square critical value. And then our test statistic, which we computed, is 7.89. And that got computed right here, 7.89. And then the p-value associated with 7.89 at 2 degrees of freedom, you just come over here. 7.89 is going to be between 7.378 and 9.210. And so that's between 0.025 and 0.01, which I wrote down here for your p-value. And so here we're going to reject the null hypotheses. And the null hypothesis is that, you know, the different proportions from the different populations of the people who would, you know, purchase again that car, that they're not equal, right? So we reject this, and that means by implication this is the one that is valid or true, which statisticians would say we do not reject the alternative hypothesis. It's like, why are you using double negatives? So that's how you do this problem. And just to review, we have, and we'll see this ChatGPT way to do it here. We have, you know, develop your hypotheses, right, for k greater than or equal to 3 populations. And the population proportions are equal is the null hypothesis. And then we have the null hypothesis cannot be rejected. We cannot detect a difference between the population proportions. And then here's our problem. The proportion likely repurchase for the population of Impala owners is P1, and then fusion and accord. And I wonder if I got that right. Impala fusion accord, Impala fusion accord. Cool, I got that right. Wasn't paying attention to that when I put the diagram together. And we determine the expected frequencies under the assumption that the null hypothesis is correct. And so there's that formula. And here's our test statistic formula in k minus 1 degrees of freedom. And I'm going to copy this here. And, you know, I feel like this slide deck, this example wasn't put together very well. And level of significance alpha is equal to 0.05. And so I'm just going to like highlight all that and put that in as that's necessary for a problem. So then we do that calculation, right? And we get the expected frequencies, and then we find the chi-square test statistic, the difference between the observed and the expected. And here's how the book talks about it, the p-value approach. And, you know, and that's the rule. And then here is the p-value approach, and they reject it. And that's, here's how you do the critical value approach. And so here, there should be, we reject the hypothesis. But I can't highlight that unless I do this trick here, which I'm going to do, just so we can make that stand out. And we'll highlight that right there and reject that hypothesis. And we'll say no fill on that. But we do want some yellow, and we'll make it 8 like that. So we reject the hypotheses. And we've concluded that the population proportions for the 3 populations of automobile owners are not equal. Of those who would repurchase, right, for the 3 populations, that's just like bad English, right? We've concluded that the population proportions of those who would repurchase for the 3 populations of automobile owners are not equal. I feel like that doesn't need to be there. We've concluded that the population proportions of those who would repurchase are not equal. I think that's good. And identify where the differences between population proportions exist. We will rely on multiple comparisons procedure. So to identify where the differences between population proportions exist, we'll do multiple comparisons procedure, which we're going to do down here. Right, multiple comparisons procedure. But that's the next video. So here is the way I did it. We already saw this. You can pause the video, take a look at it again. And to close this video out, we're going to see how ChatGPT talks about it. So here's ChatGPT's approach. Let's walk through the customer loyalty for automobiles example. This example is about testing whether customer loyalty differs between 3 different automobile brands, Impala, Fusion, Accord. Specifically, the goal is to determine if there's a difference in customer loyalty likely to repurchase or not for these 3 brands. Observed frequencies are these. Sample size is 500. And hypotheses, null hypothesis is customer loyalty is the same for all of the automobile brands. I like the way they say that. And alternative hypotheses, customer loyalty is different for at least one of the automobile brands. These are really nicely phrased. Expected frequencies are calculated with this formula under the assumption that the null hypothesis is true. And so we use this formula. And then we probably want to see here when we do this, again, I'm going to get a picture of this one here. So Command-Shift-4 on my Mac, take a screenshot and get a picture of that. And, I'm going to hit Escape and then do that once more. And I'm going to grab the observed frequencies as part of that. And so then we don't have to put in observed on that. And then I'm going to come down here and I'll go get that one. And that one is right here and it's on my desktop because that's where screenshots go. And now I'm just going to make it smaller. And there we go. So there are the observed. And we need the observed here to expected frequencies. It's going to be, let's see, they've got 312 times 125 divided by 500 for this spot, right? What is this? Column total and the row total multiplied by each other divided by the grand total gives us 78. So that's good to do those calculations. So here's our expected, right? And maybe put a little highlight on expected there. So we'll get this one and we'll just put that right here. And it needs to be like right in between. And can we get this one just a little bit more this way? That's a little bit more that way. And we'll do no fill color and we'll do like hot pink and we'll just do it to like 4. See what that looks like. Yep, I like that. That's expected and these are observed. And maybe just to make that observed stand out, we'll copy this and bring this up here and just do like that. And then just bring this over. There we go. Cool. Observed and expected now pop. So now we have compute the chi-square test statistic, and to compare this to the formula that we were given by our book, I kind of like the way ChatGPT talks about it. I'm still not totally confident why we have 2 sigmas here, though I do remember them talking about it when I read the chapter. So there it is. That's the way the book does it. Observed minus expected divided by expected, and then we add them all up. We get 7.89, and we have 7.89, so that's all good. ChatGPT is amazing, and then we determine the critical value and get our degrees of freedom and level of significance, and it's 5.991, 5.991, and make a decision. So the conclusion is at the 0.05 level of significance, we reject the null hypothesis and conclude that customer loyalty is not the same for all 3 automobile brands. This means that there's a statistically significant difference in customer loyalty between Impala Fusion and Accord owners. So in the next video, we're going to see with multiple comparisons procedure how we could identify where the differences between the population proportions exist. We'll see that in the next video. See you in the next video.